Right, okay, Jon Lewis, so that's an easy name to remember, hopefully. So I'm the Director of Strategy for Telensa, which is a company operating in smart streetlights and other sort of smart city areas that we'll talk about in a minute. So I tried to start off with something vaguely interesting about streetlights. So you can imagine a talk about streetlights doesn't sort of fill you with a lot of anticipation, really. So I had a quick look. I thought I'd try and find out when was the first streetlight and how things sort of moved on from then. So I was actually quite intrigued that the first evidence of people actually using street lighting was this is actually quite exciting. I thought 500 BC in China. Maybe no surprise that people use bamboo to pipe gas down to light up the streets, which is quite interesting. Which is actually quite a coincidence because last week. We announced that we'd shipped our 9 millionth device, and that happened to be in China. So this is actually an Internet of Things device that's using the street lighting technology, but not about street lighting. It's about connecting other Internet of Things via the street light kind of network. So this is kind of a truncated history of the street light. Kind of a boring beginning, but now we're starting to see, actually, I'll show you in a minute, that street lighting is now starting to enable various aspects of the Internet of Things, believe it or not. Aha.
Sorry.
I knew this and there was going to be a PC Mac.
Sorry,
that's
my
okay.
fault.
So we basically have a technology that we call Aptos, and this is, as you can see, it's like a cellular network that sits in a city, and it enables us to connect to things, basically. So that could be central sort of street lights. So to control them, so we'll see what we do with them in a minute. It could be smart street parking, tracking rubbish bins, all sorts of other bits and pieces, basically. So why not just use cellular to connect to these things? It's been around for a long time. It's well-proven technology. Well, if you go out and you buy an Internet of Things module to put into your little product, you're probably looking at a final product cost of around about £100 in terms of the device itself. You're going to go and get the best deal you can from EE or Vodafone, but it will still cost you about £10 a month. And, oh, by the way, the battery will only last for a week, or if it's a smartphone type thing, a hell of a lot less than that. And the cellular network puts a lot of money into rolling out its network, so £100,000 typically for a base station. Then the average cost for a cell site is around about £9,000 per year. So they're putting all this money in, which means they need to get all of this money out through selling services and connectivity. On the other hand, Aptos, we're looking at a £10 device cost. £2 is what we charge our streetlight customers to connect to streetlights per year. Battery life of around about 10 years. And our base stations, we put them on streetlights. Although we're controlling streetlights, we also use about 1 in every 5,000 streetlights. We put a base station on, and that costs us around about £50 per year to run that. So, putting that into perspective, Birmingham, we installed 33 base stations, probably less than 3 weeks, at a cost of £100,000, which is almost nothing when you look at other costs of cellular networks. And however, if you look at the application itself, your street light probably uses about £32 per year in energy costs. So if you're having to pay £10 a month for your cellular connectivity, that's not going to work as a business case. So that's why these very low cost networks can enable these applications. Some of our more exotic networks. So we now have a network in Rio, one in San Francisco. We've rolled out into Shanghai. We just won a network in Shenzhen recently. And this is St. Petersburg. So we've got a network in Moscow, and on the back of that we've recently rolled out in St. Petersburg as well. And they're not so exotic. So here's a picture. These blobs here, it's actually a bit old now, but these are actually some of our base stations around the country. So you can see we've got pretty much a big swathe across the centre of the country. We've we've got all of Wales, so we cover probably around about between 10 and 20% of the population of the UK at the moment. So in terms of, so I've spoken about Aptos, which is a general technology for connecting to things. Planet is the name that we use for our what we call a central management system for lighting. So this is just a graphical representation. So we have a base station that will typically communicate with around about 5,000 street lights. It's bi-directional communications, so you're able to tell them to do things, but you're also able to get information back from street lights. So, for example, whether the bulb has gone, and we're now also able to meter electricity usage in street lights, which local authorities weren't able to do in the past. They actually used to just use estimates based on the number of street lights they had in a particular area. Okay. So this is just a slide that I've stolen from the Green Investment Bank. So I guess lots of you know that there's now quite a big move to LED lighting. The cost of LED street lighting has now come down to the point where you can probably get a payback of investment within about 3 to 4 years by moving to LED lighting. And key figure here is 30% for local authorities' energy bills go on street lighting, which is as you'd expect, with all that power they're using to run the street lights. So there are 3 areas that we managed to get energy savings. One is called trimming. So this is about being much more accurate than you used to be with just having a photo cell on the top of a street light. So what you used to see was street lights sort of coming on sort of relatively randomly based on a little photo cell they had on the top. We're now able to control that much more accurately. So solstice? I'm trying to remember what June 23rd. Solstice. Yeah. I'm going to sound stupid if I go for that one. So quite pertinent, I guess. So actually, what's more interesting is the time in the winter. So you find that people will turn on the street lights tended to come on around about sort of 5 o'clock in the evening, which also corresponds with when everybody gets home and puts their kettle on. So it's actually peak electricity time, and you suddenly got this big use of energy in the street lights. So the power companies don't like that, and also the local authorities will be paying more money for electricity during that time. So that's why getting it accurate timing is very important. The other 2 areas are dimming. So this will show you, so at, let's see, so after midnight, for example, you don't necessarily need to be running your street lights at full power. So we provide the mechanism to drop the output to say 60, 50%, so you can save energy that way at 3 in the morning. You also have the ability, if there's been an accident or some problems, the police can actually just bring up the street light intensity immediately if they need to. This shows the output of an LED light over its lifetime. So if it has a lifetime of 25 years, you'll find that the light output degrades. So in a dumb system, what you'd have to do is you'd have to overpower the light at the start of its life unnecessarily, so that by the time you get to the end of its life, it's actually meeting the kind of minimum lighting requirements. So what we can do is put in a profile to manage that more effectively. And this kind of sawtooth thing here, you can also tie it up with when the local authority goes out and cleans their street lights, so you can make it even more accurate. So smart parking is just another example of the things we're doing. So in Moscow, we've installed a system that has magnetic sensors in the ground. The car comes over the top and sends a message to a central system, which then goes, and you can sort of tell people via mobile apps or via street signs where there are free car parking spaces. So apparently, I'm not sure I believe this figure, but apparently congestion in Moscow has been reduced by around about 27%, and the average speeds have increased. We've now rolled this out to St. Petersburg, Minsk, Kazan, some other weird places in Russia, and China as well. So, this is the final slide, I think. So, if we've got this network that covers the whole of the country, and we're doing it for next to no money, so we're able to offer these very, very low-cost services, so £2 to connect to a street light is just an example. That enables us to provide connectivity to all sorts of devices, not just street lights, not just parking, not just other sort of smart city stuff. So the area that we're moving into more now is actually consumer products. And there's a kind of dull side of that and an exciting side. The dull side is, as you'd expect, things like being able to do a child tracking or pet tracking or things like that. So we're also setting up some partner brands where we're actually going to be selling directly to consumers. But the more interesting thing, as far as we're concerned, is that if you can give it away for free, then perhaps you can enable the bigger brands to give away these kind of exciting devices and the connectivity for free, give it to their consumers for free, and then be able to create meaningful relationships with those consumers based on kind of added features that people will then associate with their brand. So that's the kind of area that we're now moving into. So that's where we think, the smart city side is the kind of hundreds of thousands of devices. This could be the millions or tens of millions of devices. So all exciting stuff. So that's it. Thanks very much.
Thanks very much.
Any questions?
Any questions? I think it's absolutely fabulous. That's so dull, it should be everywhere. It's exactly what we want.
That's nice, thanks for that.
Absolutely, you've succeeded. So, questions?
Where should we go for that?
So just two questions. First, how many you rolled out? And second, what's the technology? I missed it.
Okay.
Cellular or what?
So we've shipped 9 million devices, and that has been, the original device was actually, I don't know if people remember, or Crime Watch, there's the tracker stolen car system. So that was actually the base technology that was used in that. We've used it for smart metering. We did the first gas metering trial with British Gas about 10 years ago up in Manchester, about 50,000 units. Street lighting, we have around about, not quite 1 million, I think, but we've now got another. Our biggest market now is actually the US. So we've got just won a contract where we've just doubled the amount that we're shipping. That's all going very well. In terms of the technology, something that we call ultra narrow band. So we developed this around about 17 or 18 years ago. So this all sounds marvellous. It's low cost. You can connect to everything. Of course, you don't get, you don't. There's no such thing as a free lunch. The basic idea of the technology is you have very, very narrow bandwidth channels. So you can't stream video or audio across it. It's very much about talking with things and getting status information rather than, big streams of data, basically.
Right, super. Now, let's see someone on the left-hand side. Joe.
Yeah. Whereabouts are you based?
Just south of Cambridge.
Right. Okay. So it's all British developers.
Yep. So we do too much. Typical British company. We do everything in house. We design the radio protocol. We design the devices themselves, the base stations, the user interface, the central system database, everything. The only thing we don't do is make the chips. So we buy chips from American companies.
Where are the opportunities to use technology for consumers outside of things like kid tracking or pet tracking?
So what are the opportunities? I'm just doing it for the base and for the benefit of the recording. What are the opportunities to
What are
use
the
this
opportunities to use the technology for consumers?
for consumers?
Outside of what you've already mentioned.
Well, okay. So if you look at there's a segment of the Internet of Things that people call low power wide area. If you look at that, around about 40% of the applications in that require some kind of tracking. So it could be things like, one thing that we've been working on recently is airports and luggage tracking. So if you've got a device that you put on your suitcase, we could cover 50 50 largest international airports at £5,000 per airport. So you can imagine to actually cover them and provide that as a service is relatively cheap. Other things like, I don't know, if you look at the in-home use, there are some applications where you don't want people to be connecting via their Wi-Fi because it could be, it's complicated for old people to use, for example. Your kids may change the password on the Wi-Fi, so you lose that connectivity. So there are things like white goods, for example, where the manufacturers want to embed these kind of connectivity devices so you don't need to connect to your home Wi-Fi, but they then get an instant link through to your fridge or your washing machine.
Can I ask what frequencies you're using?
So we use 68 megahertz in the UK, which is license exempt for those techie people out there. 915 in the US, which is another license exempt.
So quite good penetration. Walls and stuff.
China is 470 megahertz,
Right.
and we've also done specials at 60 megahertz as well for very wide area coverage.
Fabulous. Right, next question. Paul.
So that's ISM band.
Yeah, that's right.
So are the protocols that sit on top of that are public and available?
Right.
So can we get a global?
So the global side of it, yes, we are global because we've got these different frequency bands, and you find that although they're different frequencies, they've all got different quirks as well.
Yeah.
In terms of the protocols, that has been proprietary up until now. However, we're not naive enough to think that in 5 years' time, that as the Internet of Things takes off, that we're going to get away with having a proprietary protocol. So we're actually putting our technology into Etsy, so the people who develop GSM. In fact, there's an Etsy meeting at our offices on Thursday and Friday this week. So we're actually actively standardising it. So that applies to the radio protocols, but the bit on top of that, we've just set up an organisation called the Wireless IoT Forum, and we've got various different, some quite big global companies involved in that as well. And the idea of that is to get the kind of set of standards around it to be, best in class standards as well. So there's some interesting things in the UK like HyperCat, for example, and IPv6, not to the end device, but to have proxies to enable you to actually address things using IPv6.
How are we doing on time? Or were you not time?
Wireless IoT.
So it's wireless-iot.org.
All right, let's take two more questions. So you are, sorry, I don't know your name.
Yeah, no, sorry, I'm involved. What's the security of the network and the data?
Excellent question. In terms of street lights, you would think a street light, you don't really need to have much security for a street light. However, that's true and it's false. So if you want to hide the fact that your street light's on, that isn't particularly secure because you can go and you can see with the street lights on. However, having somebody being able to control your street lights is a bad thing, basically. So we have encryption on the air interface, and we also have mutual authentication to make sure the device knows who the network is, and vice versa. But that is one of the big areas that actually is kind of one of the big sort of focus of the Wireless IoT Forum and the Etsy activities.
I was thinking particularly if you've got things that are tracking behaviour and stuff like that.
Right. Well, there's the whole privacy thing as well. So you need to put in place mechanisms to make sure that the core database is secure, and you can do firewalls and encryption and all that kind of stuff. But the bigger question really is whether society accepts that intrusion into the privacy side. And I think it's two things about that. One is if you're getting it for free, we do things, we give our details to Google, but we accept the downside of that information. And the second side is that, so you accept it depending on what the benefits you get. And the second thing is, just that, as young people grow up and, as the population is used to this kind of, intrusion is the wrong word, but
Sharing. Yes.
So, but it's that comes up a lot, and that's something that I think we need, shouldn't be ignored.
No, absolutely a hot topic. Right, one more question quickly. A man with a proper moustache, I'd like to point out.
We have development kits for individual developers. So if someone just wants to start hacking and also big
So there are companies who are doing that kind of model where they're rolling out networks and then they're letting anybody connect to their network. The model that we're following at the moment is to roll out the big applications, so the street lighting, the parking, etc., etc., etc. So at the moment, we deliver complete vertical applications. However, we have developed a module that we can sell to people if they've got a large enough product idea, and we're very, very happy to work with people to do that. We've got a Chinese partner who's doing that. We've shipped them modules, and they're developing cow tracking systems and all sorts of things that we don't know about. So we would like to talk to people, but at the moment we probably can't support you unless you've got quite a big application. But having said that, if the growth opportunity is there, then please talk to us, because I think we're just in this stage at the moment where we're delivering vertical applications, but the plan is very much to roll it out and make sure that there's a kind of broader ecosystem of people.
Can we, without breaking any promises, talk about the difference? And I was intrigued. Tell me if I must stop talking about this. The difference between, say, your business model and Sigfox's. Well, they are selling at per bit, and your bits may cost very different amounts of different applications. So I think this is really important.
So I don't know how many people. There's basically a French company called Sigfox, which is a startup about 5 years old, and they've got a model where they are rolling out a network speculatively and then enabling people to come onto that network. Very much like a cellular network, they're charging a kind of per bit or per device connectivity charge. And we're actually, they're going to be at the meeting on Thursday and Friday, so we're actually working with them to standardise the technology together. So we're actually quite closely coupled with them, which is quite strange. The reason that we're not following that model is if you look at a street light, the value in a street light in terms of that connectivity, we managed to get £2 per year for that. If you look at a smart parking place in the centre of the city, it's worth about £5,000 to the local authority. So as you're a network operator, do you price yourself so low that you can hit all of these applications at the bottom, in which case you're not getting the value from these high value applications, or do you try and get some of the value of those high value you know what I'm saying?
Yes.
But you're not able to provide for the kind of the lower value applications, which may also have quite high value to society as well. So the model we're following at the moment is to deliver complete solutions.
And you're certainly not alone in that, are you?
Yeah.
Yes.
But as I say, the plan at the start of moving into kind of broader set of things was to develop an ecosystem.
Yeah.
It's basically that we're not there yet in terms of being able to support people well to do that, basically.
Right.
Okay.
Thank you very much.